Hey everybody, it's time for more stoichiometry. Today we're going to be working on volume-volume equations. And in volume-volume equations, this typically happens for gases because the given and the unknown are both in liters at STP. STP again stands for standard temperature and pressure. Okay, and standard temperature, if you remember, is 0 degrees Celsius or 273 Kelvin, and standard pressure is going to be 1 atmosphere of pressure. So what we see here at sea level in Abington, Pennsylvania, suburb of Philadelphia. All right, so what we're going to see for this is going to be very similar to what we did when we were converting our moles, because our given, which is in liters, has to go to moles. And the way that we do that is by using the molar volume. And our molar volume is 22.4 liters that 1 mole will occupy. Then just like we have done everything else in stoichiometry is that we use the mole reaction ratio. And that mole reaction ratio is in essence the heart of stoichiometry. And then lastly, we have to convert our unknown back into liters by using that 22.4 liters per 1 mole. So all this information you have seen before if you're following these videos in order. Okay, so for those of you that don't remember, we are basically here and here on our mole roadmap, and we are converting to and from moles and volume. So this is your 22.4 liters per 1 mole when you are going from moles to volume in liters. And then it's the opposite conversion factor, 1 mole over 22.4 liters when we are coming back down to moles. Okay, so here is our game plan. So one thing that you can do is put this kind of above where you're doing your work so that you can substitute everything in. All right, so you have your given volume, and then we are going to change from that given volume in liters into moles by using 22.4 liters per mole. Every single stoichiometry problem uses the reaction ratio. This is the moles of our given to moles of the unknown conversion factor. And then lastly, we are going to use that STP molar volume again, 22.4 liters per 1 mole to get back into liters. And you're going to notice something interesting about these two parts as we solve these problems. All right, ready? Here we go. So this is a sample problem. It says N2 plus H2 gives us NH3. And it asks how many liters of hydrogen do you need to make 25 liters of ammonia at STP? So if it has STP, that should be little bells and whistles going off that we're going to be using that 22.4 liters. Okay, so first things first, make sure you balance this out. Okay, all of the equations should be balanced. We're going to need 3 hydrogens for every 2 ammonias because we have N2 and 2 over here. And then if we go through our problem, it says that our 25 liters of our ammonia is going to be our given. So I have 25 liters of NH3 as our given. And then it says that we want to know how many liters of hydrogen. The how, the question word, talks about this one. So we are looking at how many liters of hydrogen as our unknown. Okay, so we have liters and liters, hence volume to volume problem. But our reaction ratios are all in moles. So this is in moles, this is in moles, this is in an implied 1 mole right here. So my reaction ratio is going to be 3 moles of hydrogen for every 2 moles of ammonia. So write that down, 3 moles of hydrogen for every 2 moles of NH3. So we have to get back and forth between liters and moles at STP and then moles to liters at STP. And that is using our molar volume, which says that at STP, any 1 mole of gas, regardless of what it is going to be occupying 22.4 liters. All right, so let's write down our game plan. All right, so our game plan is always to start with the given. In this case, the given is going to be in volume. Okay, then we are going to use the molar volume conversion factor to get from liters to moles. Then we use our reaction ratio to get from moles of our given to moles of our unknown. And then the molar volume again in order to get from moles of our unknown to liters of our unknown. So plugging this in, we're going to start with our given 25 liters of NH3. Set up your 3 conversion factors that we have been doing since the beginning of the year. Molar volume is 22.4 liters per 1 mole. So if I'm starting with liters, I put 22.4 liters on the bottom and 1 mole up top. That means that liters and liters cancel out. Next, we have our reaction ratio. Our ratio is up here, 3 moles of H2 for every 2 moles of NH3, and I get that from the balanced equation. So since NH3 is here, I put the 2 moles of NH3 here and 3 moles of H2 there. And then moles and moles of NH3 cancel out. Last but not least, go to molar volume. Again, 1 mole is 22.4 liters. And as we know, if we start with mole here, 1 mole of H2 is on the bottom and 22.4 liters of H2 is on top. That cancels out moles of H2 and moles of H2. Okay, now go grab your calculators if you haven't already. I'll wait. Push pause. Did you get it? I hope so. All right, and in the calculator, we multiply the entire numerator and divide by the entire denominator in one step. So that means you enter 25 times 3 times 22.4 divided by 22.4 divided by 2. And when you put this in the calculator, you get 37.5 liters of H2. With sig figs, this rounds to 38 liters of H2. So if we take a little sneak peek back at what we did, this step right here and this step right here allowed for us to multiply and then divide by the exact same number. So really, all that this is, all that these volume-volume particle problems are, or volume-volume problems are, is taking the given times the ratio. So really, it's like a mole-mole problem. So what is 25 times 3? Well, that's 75. Divided by 2, that is 37.5 with sig figs, 38. Very interesting. So you can kind of save yourself some time when you are plugging everything into the equation. All right, so here we are going over the problem again. We have our 25 liters given, our liters of H2 unknown. This is our conversion factor, our mole-mole ratio, and we know it's always 22.4 liters per mole. And then we go through the steps again. Okay, we first put down our liters of NH3 that's given and cancel out the liters of NH3 on the bottom, having 1 mole of NH3 up top. Then we convert moles of NH3 into moles of H2 using the reaction ratio. And then lastly, convert moles of H2 into liters of H2 because we measure gas in liters and not in moles. We don't have mole scales, we don't have mole flasks or anything like that. All right, so little pro tips for you to remember. Okay, your given will always be a volume and always go here. You will always see your given unit and 22.4 liters on the bottom, always 1 mole of the given on top in the second step right here. In the mole ratio, you will see the given mole ratio on the bottom. You will see your unknown mole ratio up top. Now, this last step, you always see 1 mole of your unknown on the bottom, and you will see the 22.4 liters of your unknown on top. Okay, so that is volume with Levin. Hope you liked it. Bye.